signed up for this, and we've got about half of you now, and I guess we'll have more as we go along. But this is the Arise third coaches clinic. So our first coaches clinic, well, I guess we started out October 30th with the kickoff, and that was just kind of an informational session. And then the first clinic was on putting the drone together, all the different parts that are in it, all the things you need to be concerned about, how to participate in the competition, and where to buy your stuff and things like that. The second presentation was on, the first presentation, excuse me, was on the idea of this is how do you manage a team? How do you manage a season and other types of things? The second one, which was January 8th, was on the curriculum and how you could use this in a classroom, and how we're developing a classroom curriculum for you to do that is a capstone senior project type of thing. And then this one is about the radios. So the radios are kind of tricky. They're probably one of the trickiest parts about drones. There are a number of different things you need to be concerned about or consider when you're dealing with the antennas. You have a lot of antennas on these. They're kind of prickly with antennas because you have an antenna for controlling or for receiving and transmitting information to a remote control. Then you also have a ground control, and you have a separate receiver and transceiver for that. And then you have an antenna, which is GPS, and you also have an antenna which controls and sends the feed from your camera. So there's a bunch of different antennas, which means that there's a lot of EMF stuff going around. And then there's all the different things that are the other electrical components on your drone that could interfere with those antennas and receivers and transceivers and other types of things. And fortunately, we have Ron Pointer here to talk to the different parts of the drone that are radio controlled. So talk about all the different radio controls, talk about all the antennas, and talk about all the potential interference that you need to be aware of, and you need to probably mitigate as much as possible. So with no further ado, I'd like to introduce Ron Pointer, the president and CEO of On Point Drones. He's the person you need to talk to if you want to get a stock drone. You can build your own drone, but we probably recommend you try a stock drone that already has plans for how you put things together, has all the different parts that you need, and is in a kit of sorts. This is the drone that we train on. We're going to have trainings in the summer, and we're going to start registering teams for our competition, which is probably going to be in the second week of June, coming at the end of January. So we're going to start, the registrations will begin very soon. So Ron Pointer is going to tell you more about how antennas work and putting them on your drone. So go for it, Ron. Thank you very much.
All right. Thanks, Ken. So let me bring up my materials here. And all right. I hope everybody can see that. And so, okay, so as Ken said, my name is Ron Pointer, and I am the owner of On Point. We're a drone company that has been making and selling education kits for schools since 2013. So we're going to kick off and go through and talk about radios, antennas, and some of the things that are specific to drones, specifically as part of the Arise competition. So we will go through. So we're going to first talk about handheld remote controls, essentially the radios that you use to manually control the aircraft. Then we're going to talk about the telemetry radios that are a live channel between the drone and a ground control station. And we'll talk about those a little bit as well. And then we're going to talk about the video cameras and video transmitters that are part of the aircraft, that'll be part of the Arise competition. All right. So handheld remote controls, we're going to start there. For the most part, the 2.4 gigahertz are the most common ones used. There are some that are operated at 900 megahertz as well. And they're the handheld remote controls. Now, the radio on the bottom left is a very good radio. It's about between $65 and $70 a piece. I have been using them for years. They're very good, inexpensive radios. They can do great things. The smaller one in the upper right, that radio sells for about $130. It does not come with a receiver, where the other one did come with a receiver. And so when you get to that radio, you're looking about $150. Now, is that one bigger or better than the other one? Yes, it is. It has significantly more capabilities. But for what we're going to do with the Arise competition, it's way overkill. So if the school already has one like this that they've used for some other drone or RC aircraft project, certainly you can use it. We're all about trying to set the level entry for the contest at something that is reasonable, not a crazy expensive. You're not buying a $4,000 aircraft to compete in the contest. If you already have a drone, if it meets the specifications for the contest, you can use those pieces. We want the same thing to be with the remote controls. The remote control in the upper left corner is just a different brand. It's a 7-channel radio, as you can see. And then the 2 remotes in a little circle there in the center, those are 900 megahertz radios. They're much simpler, but they are a little more complicated to set up, as is the more expensive the radio, generally speaking, the harder it is to set up. Not always the case, but generally speaking. But these will range anywhere from about $65, $70 up to $150. And you can certainly spend significantly more if you want to, but you don't really need to. But prices will vary. So for the contest, what we want to do, you're going to need a minimum of 8 channels. And the receiver needs to be one that can handle that. Now, there's a couple. For those of you that are real radio nerds, you're going to love this today. But for those of you who aren't, I'm going to try to keep it to where it's kind of understandable. So there's a couple different ways that you can send signals from the receiver to the flight controller. And the one that's most commonly used is called either PWM, I got a misspelling here, PWM or S-bus. And those essentially send out in a serial pattern, a series of commands. So that little radio on the bottom left that has, it actually has up to 10 channels on that radio. The receiver is an 8-channel receiver, but with S-bus, you can get up to 10 channels of use. It's a little complicated, but if you have questions about this issue, kind of looking at different possibilities, we can help you kind of figure all that out. Most of the radios you're going to buy do come with a receiver, but some do not. So you just need to know that if you're going to go to purchase something, is does it come with a receiver, and then what kind does it come with? We get questions a lot about, can we fly more than one drone at a time? Will one radio interfere with another? So they will not. The newer radios, your receiver and the transmitter, you go through a process to bind them, and once you do that, that transmitter will only talk to and give instructions to that receiver. So if there's 10 aircraft out there flying, your remote control is only going to control your aircraft. So we don't need to worry about, back in the days, there were remote control planes, and they would be out flying on a field, and they had to be on different frequencies and coordinate all that. But with these, you don't have to do that. That bind process, you do it one time and it should be bound. You shouldn't have to have a problem with it. Occasionally you have to rebind it, but it's pretty rare. So with 10 channels, you need at least 5 of them to control the aircraft, and then the others are for other functions, and we'll get into those a little bit. But we're going to recommend something fairly inexpensive, but you are going to need just remember that of 8 channels or 10 channels, you need at least 5 of them to just control and the aircraft, the drone. Okay, so these are fun little things. So this is I put these up here so you can kind of see the movement. If you look at the remote control on the right and the images, you'll see that aircraft. Now this is demonstrating yaw, so it's rotating left and right. And if you look at the remote control, you can see the slider. If my pointer will point it out, that's moving left or right to make the aircraft rotate left or right. Okay, so that's what that does. And this one should be pitch. So as that as that stick on the right moves up and down, it rotates the nose of the aircraft up or down. This translates into forward flight. So the more that aircraft are forward or backward flights is probably the best way to say it. So as you move that stick to the right, the nose will pitch down, and as it pitches down, it just goes forward. As it pitches back, it goes backwards. So those are 2 of the stop. How do we go to the next slide? Now it won't let me advance to the next slide. Well, hold on, folks. It's always something. All right.
So if you have any questions, please put them into the chat and we'll answer them as quickly as we can. So this is 2 degrees of freedom that drones have. And then you've got roll, pitch, and yaw. And he's got roll and throttle here.
Yeah. Well, we're going to go through all, these are the main channels. So, and they tie into the remote control. So this is the roll. And so as you move that stick on the right-hand side of the controller, left or right, it rolls the aircraft left or right. And that's going to make the aircraft hover to the left or hover to the right. Now, this is assuming you're not doing forward and left kind of movements. There are certainly combinations. And then this is the throttle movement here. So as that stick on the left goes up or down, the aircraft's going to rise or descend. So these are just kind of fun little animations. All right. So the other uses of those channels. So those are 5 channels you need. Four of those channels. That's pitch, roll, yaw, and throttle, or 4 of them. The 5th one is the flight mode channel. So that's putting it into position mode or attitude mode or return to launch mode or one of the many different stabilized modes. There's many flight modes you can use. So 1 channel is for that. So some of the uses for the other channels are things you can add on to it. So a simple one can be, if you've got a camera on there, you can hook it into the flight controller and you can use it to trigger and take photographs or start and stop videos. On the left-hand side is a big claw, a servo goes inside there, and you can control and open and close that if you're going to release something or try to pick something up from the drone. The top right picture is actually a small servo system set up as a winch. So you can literally bring something up or lower something down using one of those switches. The middle right picture is a release, just a simple mechanical release. We've used those quite a bit for the in contests and doing things like that, just to demonstrate flying to a spot and releasing something. And then another one is to control a gimbal stabilized camera. So that's that bottom right picture. So a lot of other different things you can do with them, but those are just some common examples. All right. So next we're going to talk about telemetry and ground stations. So this is kind of a pretty beefy one here, generally used by professional folks, but we're going to kind of talk about these radios. So these radios are smaller. You'll have 2 of them. One will mount to the aircraft and the other is going to plug into your ground station, which is typically a laptop. And you can use it then to get live positioning and activity of the aircraft and know where it is and what it's doing. This is important in the contest in that as we're having aircraft compete, part of the contest is going to require you to have the students configure the aircraft and upload a waypoint mission where the aircraft will fly from point to point and have instructions along the way, maybe have it do something en route. And having these radios will allow the students to see what the aircraft is doing on the computer screen. It'll also allow the judges to monitor and see if how well they planned and executed their mission. So the top left picture there is just the telemetry radio. That's a version of telemetry radio plugged into a laptop to get that signal. The bottom left picture are typically what those radios look like, ones that we use. The prices can vary, but they started out about 2 years ago, about $35 a pair. Now they're probably close to 100 just because of chip shortage. We hope that that'll start to kind of trickle down as they're more available, but you can expect to spend about $70 to $75 for a pair of those radios. The upper right picture shows where it's mounted on the aircraft. So you can kind of see it's mounted on the top, the antenna sticking straight up. We'll talk a little bit more about antennas in a second. And then the bottom right picture again is another radio that would be mounted to the aircraft. One thing that's important to talk about when you're flying more than one aircraft at one time, each of these radios has a net ID, and there's software you can use, free downloadable software, where you can go in and change the net ID. Because if you have two aircraft out flying at the same time with two ground stations running, if they're all on the same net ID, the aircraft are going to get confused trying to figure out instructions from which aircraft they need to follow. So going in and setting the net ID for the pair of radios independently for each aircraft is something you're going to have to understand how to do. It's not complicated, but it's something that will be important if flying more than one aircraft at a time. And when we go to a competition where you've got several aircraft that are flying or they're going to fly, as they're powered up and they're in the pits and students are working on them, trying to troubleshoot or work on things, if they've got them powered up and more than one on the same net ID channel, it's going to mess up the competition, and not unless they allow the judges to understand which aircraft is doing what. So,
Hey, Ron.
Yes.
Did we designate that the ground control needs to be on 900? Because
yeah, they're 900 megahertz radios. Yeah, that's a good point. Let me go back for a second. So I've got on here 900 megahertz. There's two frequency bands that these radios you can buy them in. One is 900 megahertz, which is the US one. The other is 433 megahertz. That is what they use in Europe. So when you're buying these radios, make sure they are 900 megahertz radios and not the 433 hertz. You probably would have a hard time getting them in the US, but if you ordered from somewhere other than a US supplier, you could get the 433 megahertz. We're not allowed to use that frequency. So
we shouldn't, people should try it for the 2.4 gigahertz on the remote.
Well, we're talking about two different things here. So the 2.4 gigahertz is for the handheld remote controls, whereas the telemetry radios are always on 900 megahertz. The two-way, the handheld remotes, you can get them in 900 megahertz, but they are the much more expensive versions. So if you're going for a radio with an inexpensive price tag, you're not going to get a 900 megahertz radio for that. Those are, generally speaking, well over $100 a radio.
But we would not want to be running a 900 megahertz remote with a 900 megahertz ground station, right?
You can. We've done it. They don't interfere with each other, but it's better to keep it at 2.4 gigahertz for the handheld remotes, 900 megahertz for the telemetry radios. But you can do either, and we have. Okay. So let's talk a little bit about ground control stations. So you saw that picture on when we first started this section with a big, huge box with laptops in it. This is more common what you're going to see in a field setting. You'll have your handheld remote control, you'll have a laptop running the software, and you'll have a telemetry radio plugged into it. So that's what you're going to see and use when it comes to the contest. The picture in the upper right shows a mission that was set up. Those are those yellow dots. And then the red ones are shows the aircraft position. So you see the small red arrow, a little hard to see right there in the center. I don't know if you can see my pointer or not, but that's the path that the aircraft took. And so this is the kind of thing that students will have to create and upload. And you can see that when you're getting ready to start a mission down here, this block shows up that says take off. You slide that slider over and the aircraft will start its mission. So this is what you'll do for an autonomous mission. I'll have to create a flight pattern and they'll have to execute it. And that's all going to be done with laptop-based software. So we'll talk a little bit more about that as we move along. All right, so let's talk about carbon fiber. A lot of the aircraft out there, including ours, are made with carbon
So Ron,
fiber.
I'm sorry.
Yep.
So just to throw out there that the ground-based software is free.
Yes, I'm getting to that. Okay. So the carbon fiber is electrically conductive. So there's a couple things you need to be aware of because of that. Is you don't want wires that can get cut or exposed and contact the carbon fiber. It can cause a short, right? And a serious short, like if it's a battery wire, can cause a fire. So you want to be aware of that. Now, I will say this: in 9 years of doing this, I've never ever had an aircraft catch on fire, and I've never had a customer have an aircraft catch on fire because of shorting out like this. So it's not like it's common, but I want to make people aware that those things are out there. Also, because it's electroconductive, it can block your RF signals. So what I want to point out in these 3 pictures, we have 3 different antennas. All right. So the bottom picture, those 2 wires going out that they're black with the clear ends there. That's the receiver wires for the 2.4 gigahertz handheld remote control. All right. That's those coming out there. And we typically set them up to where they're going out at about 90 degrees. Right. You want those going out like that, so you have a very good chance you're not going to have any reception loss. Now, again, I have not had that happen, but you want to set things up so you can get good signal return. So taking those wires and taping them or zip tying them down to a side of the carbon fiber is not going to be a good idea because it's going to block those signals. All right, so you want to have those out where they can pick up signal. The image on the upper right, again, is the telemetry radio, and you can see I've got that pointing straight up. Radio waves propagate off the side of the antennas. What you don't want is the antenna actually pointing towards where you're trying to pick the signal up because it's not going to really pick it up very well that way. So you want those antennas perpendicular to the flight path. So you can see that one on the top of the aircraft is pointing straight up. The picture in the upper left is the video transmitter. So you can see there's a camera looking down right there. It's connected to a video transmitter, and the antenna for that is pointing down. Again, the waves propagate out to the sides of that. So as the aircraft is flying away, you're still going to have good video reception. All right. But you don't want to point those antennas directly towards where you're trying to, where you're flying from, because you run a risk of them losing contact. Okay. Okay. So this is a kind of a good example of how to do the antenna. So that picture on the upper left, you can see that there's that short antenna with the yellow cap sticking out at an angle. Then the 2 lower ones, those are wire antennas coming out of there, and they're coming off at 90-degree angles. And that's a good way to set those up so that you're getting good, transmission and signal is going out, but they're not going to interfere with the carbon fiber frame. The antenna, the small one in the upper right circle there, is a antenna for a video transmitter. Sometimes you see those that shape on on your drone. The middle picture, that's actually a GPS antenna mount. So it's not actually an antenna, but it is the mount for the GPS antenna. We'll talk about that a little bit in a second as well. And then the lower left picture is a telemetry radio mounted on a different drone, and you see that it's pointed down. And so you want to make sure you've got these set up so that you're getting good wave propagation. You do want to keep them away from propellers. The most common thing we'll see with antenna wires is if they're not secured, especially the ones for the handheld receiver transmitter system. Those tend to be longer. If they're not secured down, then they can fly around and propellers can cut them off. If that happens, you're likely to have an aircraft go into failsafe. Um, that's why most aircraft have 2 antenna wires to try to avoid that. Some of the smaller ones, like the racing drones, do not. But for the bigger ones, you'll tend to have 2 antenna wires coming off of there. And that's where you want to have them at 90 degrees and make sure you keep them away from the propellers. Okay. Okay, talking about cameras and video transmitters. So video transmitters transmit at 5.8 gigahertz. And the power levels can be anything from 25 milliwatts up to, and I've seen 1 watt. Now, operating in those at those high powers requires an FCC license. And there are some bands that require an FCC license to use. For the most part, the video transmitters you're going to buy for your drone are going to have enabled frequencies that you can use without an FCC license. To use some of the other frequencies, there's a requirement for an FCC, at least technician level license. But for the most part, it shouldn't be an issue if you stay in those bands. What you have to be aware of if you're flying more than one drone at one time is that you have your radios transmitting on different, your video transmitters transmitting on different channels. And you want at least 25 megahertz difference between those channels to make sure you're not going to run into interference. If you've got one radio that's transmitting at 25 milliwatts, another one's transmitting at 600 milliwatts, the 600 milliwatt radio is bound to overpower the other one and can scramble a signal, which is important if you're using that camera system to navigate and figure out where you're going. So we recommend you set them at the minimum power that you can and still see the camera at the distance you're going to fly. And keep in mind with these aircraft, you cannot fly them beyond where you can see them. So you're not going to fly them more than probably, I can't imagine flying them more than, an eighth of a mile away at the most. So as long as you're getting good video signal at the kind of distance you need, then you're fine. If it gets out and you're halfway to where you're trying to go and you're losing video signal, bring it back and then increase the power level and see what a difference that makes. The cameras, if you look at the picture, the picture on the upper right is the bottom of the aircraft, and that's the video transmitter secured to the bottom of the aircraft, connected to the camera, and then over to the antenna transmitter. The picture below it, that particular aircraft actually has 2 cameras. It's got one that looks forward and one that looks down. That one, we have a video switcher, so we can switch between views. So that's one way to do it, but it does require you to have 2 cameras. The image on the left shows a servo-controlled camera that can actually pan and tilt. Now, you don't really need to pan for what we're doing with the contest, but if you're going to have one camera, you're going to want it to be able to either look down or look forward. So having a camera with a servo on it so that you can control what direction it's looking, whether it's looking up or down, is going to be kind of important. So that's an example of that. There are certainly others, and students can certainly 3D print and design their own should they choose to. It's just going to take a fairly simple servo in order to change its pitch to see where it's looking. Pardon me. So I think that goes there. I talk kind of fast, so if people have questions, pop them into the chat. So FPV flying was first person view. Some people call it VR. It's not really VR, but first person view, it's pretty popular in racing. If you see, there's a couple of pictures of racing drones here. The Arise competition is not going to use FPV flying. They're not going to put on goggles, maneuver the aircraft around, at least not in the iterations we're planning currently. But they are going to have to be able to monitor the camera feed. And there's a couple ways you can do that. An inexpensive way, you can get a set of fairly inexpensive FPV goggles, and they can use them to monitor and see what the aircraft sees. Because this is going to be a team event where one person is going to be flying, others going to be involved in other pieces, one's going to be monitoring the video. And so using a fairly inexpensive set of those goggles is a decent way to do it. The center bottom picture there shows a small monitor that's like a 7-inch monitor. Those are commonly used as well. They're about $75 maybe, whereas an inexpensive pair of goggles is probably closer to 45 or 50. So it really kind of depends on kind of your budget, what you'd like to do, but you can take the goggles and hold them away. We don't want them flying with it that way because that's not what we're trying to do with this contest. But inexpensive FPV goggles are a good way to be able to see that, because part of the contest is going to require students to monitor the live feed from the camera to assess what the aircraft is doing. Okay, but that's not the monitoring they're doing with that is not the same as what they're going to see on the ground control station software. That's different. Okay. We're going to talk about simulators a little bit. So simulators are a good way for students to start to learn to fly without actually taking an aircraft out. Some simulators are really built around racing. So they perform and mimic the physics of a racing drone. Now, the big difference between a racing drone and one of the drones we're using in the Arise contest is there are two things. One is typically racing drones are significantly smaller, because you can have very small ones, they fly indoors, flying FPV, and there are larger ones, they fly outdoors. But generally speaking, they're smaller. Also, they don't use GPS to maintain stability. Racing drones are about maneuverability and going fast. And so some of the things that help keep an aircraft stable when you're racing, you're actually fighting against. So that's kind of the big difference. So if you're looking at a simulator to use to do some training, there are some out there that are going to be good for getting your students a handle on what the controls do and how the movement works. And they tend to work really well. There are some out there that are learning management systems that are really made for schools that are training drone pilots. And it is a system where the teachers can log in, they can see the students, what their performance did. They have different tasks to do, and they can assess, the teachers can look and see, well, they were off the path on the left side at this point, and they were too high at this point. That's a little bit much, not necessary for what we're doing with the Arise contest, but they can be really good in figuring out, getting students at least a handle on what the drone is going to handle like before they put a live one in the air, worth several $100s with a bunch of stuff on it. Let's see.
Can you talk about how these work? Like, you actually have to plug your remote into your computer?
Yeah, so if you look at the picture on the left-hand side, the upper left, you can see is a young lady there, and she's got the remote in her hand. There's a wire connected to it. It's plugged into the laptop. It's a little hard to see, but it is. And she's maneuvering the aircraft around on the screen using the remote control that is commonly used in a drone. That's that same one that I showed earlier. Most simulators, even racing drone simulators, will allow you to do this. I would stay away from the racing drone simulators. They're less expensive, but they're less of, they're not going to be a good habit transfer. If they learn to fly a racing drone simulator, you probably don't want them going out there and flying this, $1,300 aircraft, with this newly designed payload and all these things on it. And the first thing to do is try to fly it like they fly on a racing drone. So I would stay away from those, but there are others that are going to be good fits to show that. But you can use the remote control from your aircraft, plug it in, and run the simulation with that.
So are you going to go over some examples later on? Karina is asking if you could give some specific examples.
There's one called AeroSim. It's a gentleman out of Spain, I think. Let me think about that, and I'll plug a couple in. That's the one that kind of jumps out at me. I know there's a couple of others. There's some out there, that been making drone simulators for RC planes for years, and they started including drones. Now that's been more of a thing. The other one I can think of, Karina, is Zephyr, Zephyr. They make a learning management system, but they do have a less expensive one that is a free download. I don't know what its capabilities are, but they do have the full LMS system and some others. So those are the two I can think of right now. We're coming out with one as well, but ours is going to be a little more initially set up as for racing drones. The difference is ours is going to have a position hold feature, so it will fly more like a STEM drone, like an Arise drone, but the physics will be a little bit different. So it's not going to be a good fit just yet, but we're planning on having that a Rise version for our simulator, but it'll probably be sometime next year.
So one more question. Do you
Yep.
have to buy a specific remote that allows you to connect to the computer?
What you'll want to do is, before you buy the simulator, you're going to want to check and make sure that it can take that you can use a remote control of its own. I know there's been one out there, and the name of it escapes me. It's been around for a long time. It comes with its own remote control, but it doesn't. But it doesn't mimic. You can't use your remote control. It's one that's very similar, but it's not the same. But there are others out there. So during the break, I'll see if I can do a little research and come up with a couple, but I know there's at least a couple of them.
Is that same connection what allows you to do a buddy box?
No, that's a different connection. And a buddy box is, that's where you have essentially an instructor who has a wire from his remote control plugged into the student's remote control, that if the student gets in trouble, they can just take over, flip a switch and take over and control the aircraft. So that is less commonly used in this. And part of the reason is because the aircraft have GPS, they tend to be very stable, that, if a student kind of gets into trouble, the aircraft is acting kind of funny. Typically, the first thing you do is you can take your hands off the control and the aircraft will stop and stabilize. So there is as much use for buddy box, and setting that up can be a little more complicated, and not all remote controls can do that. So, all right, I think that's going to take us to a break. I'm a little bit early. So we're going to take about, about 5 or 10 minutes?
Yeah, and why doesn't everybody, if you have any questions so far, why don't you just start asking them? You can either ask them by turning off turning on your microphone, excuse me, or you can put them over in the chat box and we can answer them for you while Ron is looking up some stuff. Anybody have any questions?
Just pop them
Everybody
in the
understand all the
chat.
different frequency stuff? So you understand that this is RF frequencies. These are not Wi-Fi. So Wi-Fi with drones, there are a number of drones that work with Wi-Fi. Telos are probably the most common of those. And those have problems in schools because your Wi-Fi network often will try to interfere with any Wi-Fi network that's trying to set up in its region area. So telos have difficulty in schools because of the Wi-Fi, but these are not Wi-Fi. This is a little different, and this is not Bluetooth either. Those are different types of radio protocols. Radio is really interesting if you want to get into it. Highly recommend that if your radio leads get a technician's license through the FAA. FCC, excuse me, because that's helpful. So you may be interested in doing that too.
Let me pull up one I got here. So if everybody can see this, this is a simulator. It's made by Real Flight, and they've been around for a long time, but they made one that's a drone simulator. But this is the remote that comes with it, and it's not the same. This is not a commercially made. This is not a commercially made remote control. This is specifically made to use with the simulator. So it works. You can use it, but it's not going to be exactly the same as using the one that you have in your for your drone.
So it's made just for the simulation is not made for controlling a drone?
That's correct. It's only made, it comes essentially the box. It's a big box, and inside this is the remote control and the software. Let me.
So having that remote control isn't going to help you with your drone, though. Your actual.
Well,
drone.
it can help you a little bit in that it shows you the basic controls, because it's still the throttles on the left, throttle and yaws on the left side, pitch and roller on the right side. So it give you some basics, but it's not going to give you the exact feel for yours. So I'm going to share my screen again. So this is one of them. It only works on PCs. It's something I'll warn you, and you have to get the correct adapter. But it does. That's that image I showed in one of my slides where they have a screen. There are a couple of others out there. I'd have to do a little bit more research. The other one I'll bring up is Zephyr. And so they've got a free version, they've got a technical and flight advanced version, and they've got, and these are kind of ones that are commercially available. They also have enterprise level ones as well. So this is the one, comes with that Fly Sky radio. We offer that one. And then you've got other scenarios they've added in there. So you have a bridge inspection scenario, open line test scenario. They've got some of the cell tower and some others. So they've got add-ons you can put on there after you do kind of the basic one. But you can kind of see in the pictures here where they've got different scenarios and things to learn to fly in. Hope that helps.
Yeah. So are you planning to talk about configuring your remote, or is that like
not the remote control? That's something that tends to be fairly specific to the remote control, because I can talk about configuring the Fly Sky radio, but if someone has a different one, it's just not going to be the same. So there's instructions that come with those. The ones with our Arise drone is going to come with that Fly Sky radio, and I do have instructions on setting that up to use with a Pixhawks. But it's a little too complicated. If you don't have one in front of you, it's not overly useful.
Yeah, we were talking this summer, we were talking to some of the teachers, and they were saying that it's nice to configure the remote so that it's like their Game Boys, which is opposite of what that's going to essentially, this is a little more probably than most people want to hear, but there are essentially 4 different modes you can fly these remotes in: mode 1, 2, 3, and 4. And what you'll see, what our animations show, is mode 2, which is the most commonly used in the United States. Now, folks who are gamers using game pads, that's essentially, I think, mode 3. And I don't know, because I'm not really a gamer. I'm a boomer, so we don't really do that. But anyway, the controls on a gaming console or a gamepad are different, and I think they're set up for mode 3. And I know there was one teacher who went in and he changed his settings to fly it in mode 3 because he was younger, not a lot younger, but he was a gamer. And so for him, it was an easier way to fly. If you want to do that, you can, but I am not going to be able to talk you through how to do that. You are on your own if you do. But I know he liked it because it was more comfortable for him, and he thought his students could adapt to it better because they have that habit transfer. Maybe not a bad idea, but traditionally it's not commonly used. So. And it looks like Jane does not like real flight.
Yeah,
Jane, do you want to say some things about that?
Well, number one, you have to pair it with a specific computer, and it can't be moved from computer to computer. And then if something happens to the computer, then you can't use it. And I just had difficulties, I would with communicating with the company, and that I just don't know. I was not pleased.
It's not user friendly at all, huh?
No, it's not. And mainly is because that it just pairs with one computer. And once you use that the code, then you can never use it again.
That's miserable.
Yeah.
It is.
A lot of the way the simulator is set up, they're by an email address. And so it's one of those things where if you're going to have, say, 3 computers at your school, you run the simulator on, then you'd have to have 3 licenses, 3 tied to 3 email addresses. I don't think you can run 3 simultaneously on the same email address. I'd have to check. The folks at Zephyr are pretty good to work with. But as far as the others, I'm not sure about. I know that the AeroSim, that is a single license for a single computer, just like a Real Flight is. So you'd run into the same issue there. I think this is why a lot of folks are going to the they're using racing drone simulators, because they can be very inexpensive, but they just don't really mimic the flight physics and how a STEM drone, a larger drone, is going to operate. And they can honestly create negative habit transfers if students are used to getting a simulator. And racing drones, real racing drones, I mean, these things can go. This one we've had up to 80 miles an hour, and they can go faster. Better pilots can fly them faster than that. So and when they get into simulators, there's no consequences if they crash. So, they just go all out. And you don't want that kind of a mindset when you start putting a $1,200 aircraft that's, 500 millimeters, grab one of these here. I mean, that's a pretty big machine to have flying at, 30, 40, 50 miles an hour. A lot of big moving parts that if it hits something, it could hurt people. So, that's not something you want the students to have that kind of a mindset for. So. All right, so I am going to, I'll be here. I'll be glad to answer questions. Anybody wants to put something in the chat, and Ken can answer questions. If they're more game related, it's probably more Ken. If it's more hardware radio stuff, that's probably a little more me, but you're welcome to ask any questions that you have. And then I'll just shut up.
Yeah, feel free to ask any questions that you're interested in with regards to the game and other things, because I know everybody hasn't been able to attend all of the different workshops yet. So feel free to do that. And Eric, you're here with Jane, right? Yeah.
Yeah, I'm kind of new to the party.
So do you have any questions?
Actually, I just put one in chat. The earlier workshops, like the January 8th one, and are those recorded as well, so I could go back and go through those?
They are. We're updating our website hopefully in the next week, when we're going to put those. We're going to make those available. We're going to have the registration for the tournament, and we're going to have the actual PDF of the rules there. So yes, we are recording, and they will be available, just not at the moment. Are you outside, Eric? You look cold.
I live way out in the boonies, and the internet in my house is pretty awful. But out here in my shop, the internet's fast enough to do Zoom.
Oh.
So I'm sitting next to a little space heater. It's the only place where I can get good internet.
Wow. That's dedication. Thank you.
Oh, no problem.
So does anybody have any questions about the rules or how things are going to go? Everybody knows that most of the discussion today is, well, the discussion on the ground control is going to be almost all about the automated component of the competition. And then we're going to have a teleoperated component where the kids will fly the drone and try to place golf balls, are these wiffle golf balls into different types of wading swimming pools or buckets, and they get different points for each of those. It's fairly inexpensive parts and components. So that's what it was intended for, and I don't think it's real expensive. You can get everything you need at a local Walmart to practice and or to have a competition. So the rules for the teleoperated are you need to have a drone. The drone needs to match the stock requirements, and then the drone will have to take off. You fly it in a field about the size of half a football field. At each corner of that football field are a wading pool, and in the middle of the wading pool is a 5-gallon bucket, and your job is to drop these golf wiffle balls into the wading pool or the bucket, and each of the balls have a different value to them. Each of the balls that land in the wading pool are 1 point. If a ball lands in the 5-gallon container, you get 5 points. And that's the basic competition. I think it's going to last. You've got 3 minutes to put as many balls in the space into the wading pool or the bucket as you can. And you get multipliers. So the multipliers are when you put balls in 2 or more of the different containers. So you've got 4 corners. You have 4 different possible targets or scoring places. If you can put any of these wiffle golf balls into 2, then you get a multiplier of 2 on your score. If you can get them into 3, then you get a multiplier of 3 on your score. And if you can get scoring pieces in all 4 of the scoring areas, then you get a multiplier of 4. So you get whatever points you get, and then you multiply them by 4 for getting them into 4 different scoring areas. And then on top of that, you have a multiplier of the lowest number of scoring, the lowest score in the in a multiple scoring area. So if you have balls in all 4 of the scoring areas, you get a multiplier of 4. And if in one of the scoring areas, you got 2 golf balls into the wading pool, but none in the 5-gallon container, then you can multiply by 2. So you get the number of golf balls that you scored is 1. You get the number of targets that you hit, which is 4, and then you get 2 more, a multiplier of 2, because you got your smallest, or the target you got the least in was 2. So if you were to equalize, the intent of the rules is that you use all 4 targets, and that you try to deliver an equal number or a similar number to each of the scoring targets, and that determines your score. And then you'll probably get 3 chances to score as many points as you can in that. And then we have a separate competition for autonomous, and then a separate competition for your design presentation, and then a final presentation on your teamwork and kind of project management. So those are 4 different ways that you can score. So you shouldn't just focus on the competition or the teleoperated competition by itself. Yes, Valentine, they are on the website, and that's the arise.org website, Rise Drone, excuse me, .org website, has the stock recommendations, and I think we have the rules up there too. We will have let me put that in here, https arise drone.org. If you accidentally put Arise Drones, I think you'll still get there. Oh, wait a minute. So that's how that goes. Let's see. The autonomous portion is all through Q ground control. That is correct. Yes. Okay. And then no programming in language like Python. Not
No.
yet, but we're going to get there. This first year, we're just going to use Q ground control, and we're not telling you what your Q ground control is going to be. So when you get to the competition, you have to set up your Q ground control to achieve your objective in the autonomous mode. Because if you know what the objective is and you can set it up in advance, it becomes a bit elementary to do that. So we're not going to have very much programming in this, but in years moving forward, we're thinking of adding an Arduino or Raspberry Pi to the configuration. The South region is in Dallas. So I presume that's what you're asking, Valentine. Dallas is going to have the competition this summer, probably the second week of June. I think there's going to be a team from Chicago coming down. There may be some teams that are outside of the region that are going to be competing, but it's primarily going to be Dallas, Fort Worth teams. Karina is going to come in, she said, from Austin. It would be great if we could have Jane and Eric come in from the Crowley area. So we'll be having the competition here in Dallas. Now, Valentine, where are you from?
I'm at north of Dallas, so
Oh,
just,
okay.
about 45 minutes up. I'm at Little Elm, which
Oh,
is
perfect.
west of Frisco.
Yeah, I know you guys have been into drones for a while now.
Yeah, we've been trying to push it and getting things. I mean, so I'm considered to be still a rookie, so I'm trying to learn all this, and
Yeah.
I should be taking my 107 next month. So
Oh, good. That's not going to help you be a very good drone pilot for some reason, because they haven't really figured that out. They just kind of took the part 107 from the pilots program, and there's a lot of stuff in the Part 107 that is not particularly helpful for drone pilots. Like you have to know how to maneuver around an airport. If you're a drone pilot, don't do that. Don't go to an airport and start to try to move around and get into traffic patterns and other types of things like that. That is a great way to get into a whole lot of trouble. So,
All right, with that, Ken, I think we're going to pick back up.
okay.
So, all right, so I'm going to kind of walk through. Let me share my screen. All right. Always harder to figure out. All right. So we're going to talk a little bit more about the flight controller. So I'm not going to get too much into it because we've kind of been through it in another session, but we're using an open source flight controller, Pixhawks, that's required. And we're also, the software used to configure it is open source as well. So I'll talk a little bit about those. All right, so open source software. So the most commonly used for Pixhawks is either Mission Planner, which is written in is PC based and only PC based. There's Q Ground Control. There are a couple of others. Now, show examples of these two, Betaflight and iNav. Those are typically used with racing drones. So we are not using those, but they are examples of open source software. So the bottom two pictures, the left is what Mission Planner looks like as you start to open it. And the right is a mission on Q Ground Control. So I personally like the interface with Q Ground Control, but I have used both. So you're welcome to use either one. Most of what we're going to have in demonstration is going to be showing Q Ground Control, but the interfaces are relatively similar, but there are differences between them. The other thing to talk about is there are two firmwares you can use with the Pixhawks flight controller. One is called PX4 and the other is called ArduPilot. They're both open source firmwares. You can download PX4 in Mission Planner or ArduPilot in Mission Planner. You can also do the same in Q Ground Control. Which one you use is really up to you. There isn't a whole lot of difference between them other than in ArduPilot, you have a significantly increased number of flight modes. But for the most part, they're not going to be ones you're necessarily going to use. You're not going to use an acro mode. There's others you're not going to use, but there are differences, but you can use either one. What I'm going to walk through today is kind of using Q Ground Control because it can run on a PC, a Mac, a tablet. It has a lot more options as far as how it runs or what platforms you can run it on. Whereas Mission Planner is strictly PC, but I know most schools have that and you're welcome to use either one. All right. So this is kind of what it looks like when you first spin it up. That's our offices here at in Dallas. So that's kind of what it looks like when you first spin it up. So the first thing you do is you plug your, you'll have your flight controller plugged into it and update the firmware. You're going to unplug it and then plug it back in. And once you do, it'll recognize it and it'll start to upload the latest firmware. It will typically ask you, do you want PX4 or do you want ArduPilot? And you can pick either one and you're welcome to try either one. This setup I'm going to show you going through Q Ground Control is using PX4 software or firmware rather. If you decide to use ArduPilot, you can still use Q Ground Control to set it up. It's just the setup is going to be slightly different. It may look slightly different what you're going to see here using PX4. So the first thing I'm going to do is going to ask you what aircraft you're operating. So as you can kind of see here, you've got the top one is a quadcopter in a plus configuration. The one to the right is firmware written specifically for a Team Black Sheep Discovery aircraft. You can kind of see it's not exactly a square X. And then there's other aircraft. There's a car, a Traxxas vehicle. There's an airplane. There's a all kinds of other things. A lot of different kind of firmwares you can use. So what we typically will use is something like a generic quadcopter configuration. We'll select that one. And then once you do, this window will show up as a summary and tell you all the things that you have to do. So it shows green that you picked out the airframe that you want. The next you have to go through all these and set them up. And so you can go using these boxes on the screen, or you can use the ones on the left-hand side. They take you to the same place. All right. I typically, pardon me. Now, before you get to this point, you'll have to have your your radio connected and configured, the receiver, transmitter talking to each other, battery connected. There's going to be several things you're going to have to do as you go through this process. But I'm just going to kind of walk through the steps, assuming your aircraft is fully built and assembled. Okay. So the first you're going to do is you go through, hit the radio tab or bring up this screen. Then you're going to hit the calibrate button. And once you do that, it's going to walk you through all the settings you need to set that up. It's going to have you move the left stick up and then down and then left and then right. The same with the right stick. Then it's going to have you move all the other buttons. And as you use the software, when you have it connected to a PixHawk, it will tell you exactly what you need to do. And it shows up just underneath this calibrate button. It tells you what you have to do. And so you just go through all that process. Next, we're going to talk about the sensors. Now, there's a lot of sensors on the aircraft. If you look on the left side of this window, you see it's got compass, gyroscope, accelerometers, level horizon. Okay, those are the ones that we're going to go through and configure. So when you're doing the compass, it's going to have you pick the aircraft up and rotate it. It's going to have you put it upside down, nose up, left side down, right side down. Go through all those process for all of them, okay, and have you rotate those. And once it has enough information, the box will turn solid green and say completed. So if you take the aircraft and say you put it nose down, it will sense that it's nose down, and then it will turn that one yellow like the center screen is, and it will tell you to rotate it. Now, you can rotate it in one direction. You can rotate it back and forth. It doesn't really make a lot of difference. That's what the screen shows there. Also, I typically recommend when you're doing this, get a 10-foot long USB cable. Okay, all of these flight controllers use either a micro USB or a USB-C cable. Get a 10-foot one, because as you're moving the aircraft around, you want a little more room. It gives you a little bit less, because if you're on a 3-foot cable, can make it pretty tough to go through all that configuration. So get yourself, spend the $10, get a 10-foot cable. It's well worth it.
Hey, Ron,
Yes.
can we stop for a second and can you explain the setup for this? So you now have a computer that's connected to a USB, and then the USB-B is directly connected into the PixHawk. Correct?
Right. That's correct. Sorry, I apologize. I've done this for so long and so many times. I just go through and kind of skip steps that I think people should, that everyone knows when they're not. So anyway, yeah. So the setup is that you'd have a fully assembled aircraft without propellers on it, by the way, fully assembled aircraft. You have you have a battery ready. You've got the remote control. Everything's powered up. When you plug the USB cable into the flight controller, it has enough power to spin up that flight controller and power it up. You don't have to have a battery connected to it to do that. You need a battery when we go through and do the power settings. So that's kind of the last thing where you need a battery. But all you need to do is have your laptop or a computer, doesn't have to be a laptop, with either Q ground controller, mission planner up and running. You've got your USB cable connected between the laptop and the drone, and that's when you start going through all this process.
So you don't have to connect the remote to the computer as well.
Well, the remote doesn't connect to the computer. The remote's going to connect to the remote's going to have batteries powered up, and then the receiver's on the aircraft. And then when you power up the flight controller with your USB cable, it has enough power to turn the receiver on. So when all that happens, your receiver and transmitter should be talking to each other. You should have already gone through the binding process. Your radio's already set up. I just really kind of focus on the software. When we do the in-person coaches clinics, those are going to be several days long, and those we will go through completely building an aircraft from zero, from a box of parts, all the way through the process, all the configuration, all the setup, and then go out and do the flying. And then we'll do autonomous missions. We'll do the whole thing when we do the in-person ones, but it's a little too much to kind of go through on a Saturday morning to go through all that process. So I'm kind of focusing on the software, so that you can kind of get an idea of the process for that. And then the last couple of slides, I'm going to talk a little about autonomous missions and how you create those. So anyway, on the left-hand side, you can see you've got compass, gyroscope, accelerometer, level horizon. And so what we'll do, I usually just tap the first one, go to compass, and go through that process. When all of these boxes are green, that compass, that little red light by the compass bar is going to turn green as well. Then I just click down on the gyroscope, and it tells you right on the screen exactly what you need to do to calibrate these. So when you do accelerometers, you have to rotate the aircraft as well. When you do level horizon, literally you set the aircraft in a level place, hit level horizon, and it zeroes out and levels the horizon. So they're pretty easy steps that you're going to go through to set all this up. So let's see, that's holding it still. That's for level horizon. This one should be for gyroscope. Again, it's going to put it in position and hold it still. Now, whether you're using PX4 firmware, ArduPilot firmware, or whether you're using, Q ground control or using Mission Planner, the steps are going to take it the same. The descriptions and the images will look slightly different. And you're welcome to, they're free software. You can download them both, look at them both, see which one that you're the most comfortable with. So anyway, that's to go through and calibrate the sensors. And once you calibrate all the sensors, those little lights will all be green. And then you kind of go to the next step. So the next step is going to be picking a couple of things. First of all, mode channel. Now, as I mentioned earlier, you need 5 channels to control the drone. Okay, so one is for the throttle, one is for pitch, one is for roll, and one is for yaw. The 5th one is the mode channel. And for the Pixox, we use channel 5. Right, so you can see there it says mode channel, and I got channel 5 selected. Right, then you can pick up to 6 flight modes. Now, unless you have a remote control with a 6-position switch, which very few remote controls have those, you'll be able to probably just get 3. All right, and so what you'll want to do is pick the ones that are the most that are going to be the best for what you're going to do. So you can see here, there's one you can flip to takeoff. You've got a follow me mode. You've got and follow me or follows remote control, by the way. Altitude mode, manual mode, mission mode, position mode, hold, offboard, acro. There's a bunch of them. And when you get into ArduPilot, there's even more. But the ones I think that are important that I think everyone should have, position mode is the one where it uses the GPS signals from your GPS antenna to help keep the aircraft stable and in one place. If all is set up right, with all the calibrations done, all the accelerometers and everything calibrated, and you have it in position mode with good GPS lock, when you put the aircraft in the air, it will hold its position to within probably about 1 to 2 feet. And that's even in pretty significant wind. Most aircraft can handle about 10 to 12 mile an hour winds, but the aircraft can fly about 20 miles an hour. So theoretically, it can hold itself in position in a 20 mile an hour wind, but we don't recommend you flying in anything above about 10 or 12 miles an hour. It just gets too hard to control. So anyway, position mode is going to be one you're going to have on there. The other one is stabilize mode. Now, stabilize mode is not what you think it is. Stabilize mode uses all of the onboard sensors except the GPS signals. So it will hold it level. It will hold its height because it's got a barometer. It will keep it in position, its orientation. But what it will not do is hold it in one position. So if the wind blows it, it will blow with the wind. If you fly it forward, once you back off the pitch stick to stop it, it will continue to glide just because of momentum. Whereas when it's in position mode, when you let off of that stick, it will flare and it will stop. All right. So, but stabilized mode is good in that if you are having any issue with GPS, you can put a stabilized mode and you can still control it and bring it down and back. Again, it is harder. It's more challenging to control in that mode. Typically, what I'll do is I'll use position mode, stabilized mode, and then I'll set one switch for mission, and that is to put it in an autonomous mission. So if you put a survey map together, or if you have a waypoint flight to do, you flip it into that position, on that 3-position switch into that mode, and it will go into and start executing that flight mission. On the remote control, like I said, you've got typically the ones that we use anyway have 4 switches at the top. 2 of them are 2-position switches, 2 of them are 3-position switches. I will typically set one switch up as an arm switch. Okay. It will, and I usually use the left switch over by the throttle. So you flip it down and the aircraft is armed. Now, most of the aircraft also have a safety button on the GPS antenna, or a safety button on the aircraft you have to press to arm it at the aircraft as well. You can go into configuration or parameters and you can disable that, but for the most part, I like leaving that on. So you'll press the button on the drone to put it into an arm mode, and then that one switch on the left will arm it. You can arm it with just the throttle stick as well. There's a different way to do that, so you don't need to, but that's what we recommend. Then the switches on the right-hand side, you have a 3-position switch, and again, I use those for mode. So I'll use it for a stabilized mode, position mode, and mission mode. And then the other 2-position switch on the far right, I will set as a return to launch switch. So if you're flying along, something's going wrong with the aircraft, or it's not following its mission, or for whatever reason you want to bring it back, you flip it into RTL and it will stop, turn, head back to where it took off from, and land itself. Now, that will all work just fine as long as you have enough battery power for that all to work. So if you start getting really low on battery, it may put itself into RTL and come back. Also, we can geofence these, and sometimes if they hit the boundary, you can set it to where if it hits that boundary, it will fly back and land. You don't necessarily want to do that, but anyway, on this here, you can see where you can select the different flight modes, and you can use those there. So we'll move on from that. Okay, help. Because this is these are open source systems, there isn't a company you can call and say, my aircraft isn't working right, I'm doing this, what do I do? You and your students are going to have to go into the forums and look up these problems, and you can typically find the answers there. If it's looking for parameter settings, or if you're looking for some particular problem, you're going to have to go in there. I will tell you also, a fair amount of the time, if something's not working right when you're doing the setup, you have to just shut ground control down, reboot your flight controller, power it down, power it back up, and try again. Because these are open source systems, there is now one company that makes them. And so there's not one company that will tell you how to fix the problem. So they have to do a fair amount of exploring to get that to work. But that's just kind of common in the way it is. All right. Next we'll go into is power. Now, what we do here is a couple of things. First of all, we tell it the number of cells in our battery. Most drones will fly on anything from with a Pixar, from a 3-cell to bigger ones will fly maybe with a 12-cell battery. So you're talking about each cell fully charged is 4.2 volts. Empty, they're 4.05 it says. You can get typically a little bit more out of them. They'll be at fully charged, a 3-cell battery will charge to about 12.6 volts. And then empty, you get down to about 3.4 volts per cell. And so you want to set in there the number of cells your battery is. Most of them you're going to have are going to be 3 or 4 cell batteries. So you make sure you have that number set as 3 or 4, whatever your battery is. Okay. The next you're going to do is you're going to do.
These are always lithium polymer.
Yes, though there are some companies that make drones with lithium ion batteries, but for the competition, I think you're going to use, it's all going to be lithium polymers. The reason is the lithium polymers have a very high discharge rate. And so they can handle wind better, they can handle payloads better, things along those lines. Most drones that are like this are going to come with a lithium polymer battery. What you have to do, part of the aircraft, there are what they call electronic speed controllers. And you can have individual ones, you can have one where you have a block of 4 in one device, but they have to be calibrated. And so to do that, you click on the little button down here that says calibrate. Now, what it's going to do is going to bring a pop up a block to remind you, make sure you don't have propellers on the aircraft. And I'm going to say one more time, there are absolutely no reason to have propellers on an aircraft if you're in the shop working on it. You don't need to put propellers on the aircraft until you're ready to take it outside and fly it. And I know students instinctively want to put propellers on the aircraft once they have it built. They can't do it. Take them away, put them somewhere else. But you don't want them putting propellers on it and then going through this setup process, because when they go through and do the calibration and test the motor rotation, they're going to be turning those motors. Now, the software will warn you several times, make sure propellers are off, but I'd like to reiterate that. So anyway, you're going to press that calibrate button. It's going to tell you to unplug the USB and plug the battery in. And when you do that, the aircraft is going to power up, and then the ESCs and motors are going to make all kinds of happy, funny noises. And then at the end, a little window is going to pop up and say, your ESCs are calibrated. It just happens that fast. It's that simple. Okay. So it's a real easy process, but it's something that has to be done so that, because what's happening is that flight controller is sending signals out to each motor, telling each motor how fast to turn. And it's doing that, whether it's counteracting the wind or it's following your instructions. If you want to make the aircraft fly forward, the 2 motors in back are going to speed up. It's going to tilt forward like that. And so if they're not all 4 calibrated the same in sync, then one might spin it faster than the other. And instead of going forward, it's going forward and right or forward and left. So that's why it's an important thing to do. Okay, but it's a simple, easy process to do. Okay, so this is kind of the warning it gives you. Make sure propellers are off to do the calibration. All right, the safety screen. So this one's kind of important. This kind of tells you what to do if something goes wrong. So this is the first one. I know there's a warning screen in the picture there. You can't see very well where it says lost manual control, but the battery icon there. So on the fail-safe action, you can have it do a couple of things. One, you can have it warn you, which is fine if you have some way to hear it, because what it'll do is it will literally on the computer screen will say battery at such and such %. Okay. But what we want to do with since we're dealing with students, we want to make sure we keep the aircraft under control. If you click that window and pull it down, it's going to give you a couple things. One is you want it to warn you when the battery, say, is at 30%, but you want it to fly back and land and go into fail-safe when it's at 7%. Okay. Now those numbers are all fine as long as the aircraft is within a reasonable distance. If you're flying within a football field or a soccer field, if it goes into fail-safe, there should be plenty of battery for it to get back and land itself. If you're flying well beyond that, you're out at a farmer's field, or you got the aircraft pretty far away, you got to make sure there's enough battery power left for that aircraft to get back. So if you're flying longer distances, remember that you have to keep the aircraft in your line of sight. Let's say you're flying it over a big field somewhere, and you may want to set the battery fail-safe level at say 10 or 15% to make sure you have enough power for that aircraft to get back and land itself. Right. That's if you lose signal between the handheld remote control and the drone. And keep in mind that handheld remote control is really a primary control link. When you're on an autonomous mission, you've uploaded the mission to the aircraft, it launches itself and starts flying, but you can still take manual control of that aircraft from that remote control. It isn't like once it's on an autonomous mission, you can't do anything, because you can. All right. So this next one is if you have if you lose a signal. So the first one was if the battery gets low. The second one is if you lose signal between the handheld remote control and the drone. Now that can happen for a couple reasons. Someone can drop the remote control and the battery pops out. The battery is run down. Who knows what could happen? If it loses signal, what you want it to do is you want it to return and land. This is set up for a half-second delay. If it loses signal for a half a second, then it will go into fail-safe and fly back and land itself. Okay, and that's what you want it to do. The next one down is if you lose telemetry link. Now, that's if it's flying an autonomous mission and it's loaded and it's flying and it loses link. Now, losing telemetry link is not overly uncommon. And if the aircraft is on an autonomous mission, it's loaded onto its flight controller. All that signal that's coming back from the drone is telling you on the laptop, on that screen, where the drone is. It's not really controlling the drone. It's just monitoring, giving you signal feedback of where it is. All right. So if you lose that, say momentarily, you lose it for a second or two and it pops back on, you don't want this to go into fail safe every time it loses that link. So we tend to just to disable that. So in this one, it is showing it's on, but we tend to disable that. All right, let's see the next one. So as you scroll down that page, you've got the geofence. Now, geofence is pretty important. What we like about these is you can geofence it and set it up so that it has a max radius and a max distance. All right, so you can set it to where when it goes to, if it hits that max altitude 100 feet, it won't go above it. All right, when it hits that max radius of 100 feet, it won't go beyond it. What we typically will set these at while you're learning to fly, while you're doing it, we'll set a max altitude of about 100 feet. All right, you can set it higher. Just know that you cannot legally fly a drone above 400 feet in Class G airspace. If you're in less than Class G airspace, you're going to have other restrictions. Just you know what those are. 100 feet's a good place to start. And then the max radius we typically set at about 150 feet. So that's a radius, it's about 300 feet around. That's about the size of a football field. Now, it's obviously just a complete circle, but that's a good distance to have so that the aircraft, it won't fly out where you can see it. It won't go over a neighbor's house. It won't get in front of a school bus. You know, it's a good way to kind of keep control of it so that it stays within line of sight and it won't get away from you. If you're flying in areas that are bigger, you're certainly welcome to change those. Just keep in mind that the regulations of what they are with that. Okay. Then when you have, next is return to home settings. As I mentioned, when this goes into fail safe, whether it's because of low battery or it loses a remote control signal, this is what you're telling it to do. This is telling it to go to 98 feet. You can set this at whatever number you want. Just keep in mind that if you've flown it and you've flown it around a big tree and the tree is at 105 feet and you tell us to go to 98 feet, if it tries to fly back through that tree, it's going to be in that tree. But the aircraft is either going to go to that altitude, whether it's climb to 98 feet or descend to 98 feet. It's going to go to that altitude, and then it's going to fly back to where it took off from. And then this has got loitering for 60 seconds. Typically, if you're going into this mode, you can just have it come back. You don't have to have it loiter. And then this is really more set for an airplane where it's going to loiter in orbit at one point. But with the drone, when it's a quadcopter, it'll say to loiter some time, and then it's going to tell you just to land. And so the next block down shows the essentially landing speed. It's going to land at 1 mile per hour. That's how fast it'll descend. And then once it's on the ground, it's going to disarm after 2 seconds. So, all right. So that's really kind of what I want to cover for the setup. Now I want to talk a little bit about autonomous missions, since that's kind of an area that fair folks don't have a lot of experience in. So this is kind of what the screen looks like when the aircraft is executing an autonomous mission. So you can kind of see here, you've got H is the home point, T was a takeoff point, and then you've got points 2, 3, 4, 5, and 6. And that red arrow point there, that is essentially the aircraft. So this is a screen recording of a live autonomous mission that someone set up to do. If you look here, he's at 17% battery power. So he's at the end of his rope when it comes to that. But you can kind of see, this is kind of what it's going to look like. This is kind of what the screen looks like. Setting up a mission, that's what it looks like when it's being executed. So setting up a mission, you're going to go into Q ground control. On the left-hand side, you can see you've got whether you want to add a waypoint, set up a pattern. And when you click on pattern, it's going to pop out and say, do you want to do a survey? Which is what this screen is showing, a survey, a corridor scan, or a structure scan, okay? So a simple one to do is just to set up use the button above that says waypoint, and you can just set a few waypoints. So what you want to do the first time around, set 2 to 3 waypoints and then have it come back and land. Make sure it's going to execute that. You don't want to set up a really complex, survey mission over, an area that you maybe don't have great, if you're flying over, a field that's got grass that's 3 feet high and something goes wrong, the aircraft lands out there, it's going to take you a while to find that aircraft in 3 foot of grass. So you want to do something simple to start with, to make sure it works, validate the systems, and all that things are going to work. Okay. And then you can see here that on the right-hand side, they're pop down. So you've got the camera settings there, you've got the angle you can set it at. But as you go to the waypoints as well, if you're doing waypoints, you can designate specific altitudes that you want the aircraft to be at each point. And so as part of the contest, what we would do is say we want the aircraft, the students have to program a flight, and they have to go to the first waypoint, has to be at least 200 yards away. It has to have it has to be at an altitude of 75 feet when it gets there. It needs to wait there for 30 seconds and then fly to the next waypoint. At the next waypoint, we want it to be 120 feet. We want it to face south, whatever the instructions are going to be. So you can go in there and you can tell it exactly how you want it to act at each waypoint, and the transition speed and all those kind of things. And so the judges are going to have matching telemetry modules so they can see the aircraft and what it did. Also in Pixhawks, kind of a fun thing, you can download the flight logs, and you can download the flight logs, and then you can upload them to a website that will send you an email with a very big printout of how that aircraft performed. It's got a map that shows what it did. It shows what flight mode it was in while it was doing it. So it's a really good way to analyze and see how the aircraft performed and what it did. You can also look at power settings, flight modes that it was in at different points. So it's really some really great stuff to show. So some real advantages with this Pixhawk flight controller. Like I said, some of the disadvantages are just that it is an open source. It isn't like you can call a company and ask them what the problem is. There's just a lot of digging you got to kind of do on your own. But anyway, this is kind of what an autonomous mission is going to look like in the planning stages. And here you can kind of see down here, it's got waypoint. You've got settings where you want the angles. You got latitude and longitude. One thing we do not recommend you do is have students go in, or anyone go in, and plug in a latitude and longitude, because you can see these are about 20 digits long. Okay, you change one digit in that, you transpose one number in that, and that aircraft is not going where you think it is. And if you transpose one in the closer to the decimal point, it's going nowhere near close to where you want to go. If you got the last one, it may only deviate by a quarter of a mile. You do the first one, it could deviate by mile, which you can't obviously get there, but now it's flying out of control. So you don't want to do that. But you can go in and set these waypoints. You can set altitudes. You can set headings and those kind of things, so that when the aircraft goes out to fly, you can see this is a very simple pattern where it's going to fly from one point to the next, and you can have it change those things. And so this is something good to start after you've done at least one where you're flying to like 1 or 2 points, make sure it works. Then doing something a little more complex like this is what you're going to want to do. Okay. And that is all the material I have for today. I hope, Ken, that was enough. The gentleman who we'd hope was going to do this had to bail, so I was jumping in to cover. So anyway, we're going to open it up to questions and I hope answers.
I have a question.
Yeah, go ahead.
On that software we were just looking at, it had aerial picture of where you're setting those waypoints. Where did you get that first picture to plug in there to drop those points on?
I didn't. The software, Q Ground Control has maps, whether they're Google Maps or whatever it is, but those maps are all part in there. So when you open up the software, the first thing it's going to do, you're going to want your computer connect to the internet. But once it knows kind of where you are, or when you're setting a mission up, let's say you're not doing anything close to where you're located, say you're doing it, a half mile away or 10 miles away, you're going to go over to that area where you want to do it. It'll populate those maps in there, and then it'll save them into your computer. So the maps are always going to be there. You typically will have to have an internet connection, at least while you're doing that planning. If you're trying to plan a mission, in Africa from here, could be a problem. But if you're trying to do it, close by, it's already loaded.
Gotcha. Thank you.
Mm-hmm.
So Ron, what's the difference between arming and binding?
So binding is a process where, here, I find that visual aids are important. So transmitter, receiver. Okay. Binding is a process to get these two to talk to each other and no one else. Okay. So that process, when you get these, sometimes these come already bound. That's less common these days. So the process to do that is you have to power this up, and you have to put a little more detail than we probably wanted, but they all come with what's called a binding plug. And it plugs into a port on here. Essentially, all it's doing is shorting two wires out and puts it into bind mode. Then when you power this up, you'll have your receiver wire will plug into there.
The receiver wire then plugs into the.
It looks like something like that. The other end of it's going to plug into your PixHawks. Okay. Then you're going to power it up, power the PixHawks up. It will power the receiver up. What you're going to do with your radio is, now this is mine, so it's maybe a little for you, is you go to the right tab, and there's it's probably a little hard to see. It says bind to RX or RX bind, and you tap that. I think you can see that. It does that. Now, once you power up the aircraft, get power to this, it will bind. Just like that, it'll bind. It'll say binding RX, and it's done. And you'll know it works when you look on your screen. Now, this radio, and others are different, is you can see up here at the top, right here. There you go. You've got two battery icons. So one of them is the transmitter, one is the receiver. When they're talking to each other, you're going to get a battery voltage indication on the receiver. You'll have it on both of them essentially. Okay, so that's how you know they're bound. Now that's this radio. Other radios bind differently. Sometimes it's just it's a flashing light indication. Each radio is going to come with a set of instructions, and some of them are incredibly thick. I wish I had one here. So some of you remember I showed in the early pictures a radio that I said it was about $120, about $150 with the receiver. Okay, this is the manual for it. Okay, versus the manual for this other radio that's about maybe 10 pages at the most. Okay, so that one can do a whole lot more, but you're going to spend a whole lot more time reading through to figure out how to do it. All right, I'm not saying don't. I'm just saying you need to be mentally, I want you to know what you're getting into. You buy a $150 radio, it can do a lot more, but you're going to spend a lot more time figuring out how to make it work. And maybe more than you want to take on, first time around if you're dealing with kits like this.
So once it's bound, it will always be bound to the same receiver.
Unless something goes wrong and it loses its bind. That can happen. But you'll know that right away because you're going to spin the radio up and you'll see that you're not getting a battery voltage. I've seen where you have a school that has, say, 5 aircraft and they go out to fly and they've got 5 remote controls, 5 aircraft, but remote control number for drone number 1 is being held by the guy who's trying to fly drone number 2, and so we recommend you have several aircraft, label the remote controls, little colored dots, number 1, number 2, number 3, number 4, label the drones the same way, or at least the receivers the same way, especially if you're going to be taking the aircraft apart, putting it together year over year, which most drones for this competition, you'll be able to do that. It isn't like you build it once and you can't ever take it apart again. They're designed that you put it together, build it, fly it. At the end of the semester, at the end of the school year, take it apart, and then the next group of students come in and they're going to go through and build it. But yeah, you're going to want to make sure that you've got those paired up and labeled.
So when you set up the Q ground control for 98 feet, that's not absolute 98 feet. That's 98 feet from where it started.
No, that's an altitude. That's 98 feet from the ground. And that's based on, essentially what it's using. It's got a barometer. And essentially it's using that barometer. It's zeroing out when it's on the ground. It's 0 essentially. So when it goes to 98 feet, it's 98 feet above the ground. Or what the barometric pressure. They do not have radar altimeters. They don't know exactly how many feet off the ground. It's a barometric pressure reading that is converted into the number of feet. Or you can do it in meters. You can do either one.
So I guess there was a horror story in a competition where one of the drones was set up for a geofence, and the geofence was at their school, and then they took it to the competition and the drone immediately flew off to the school. I guess they were flying back to the hotel. So do you know where they messed up?
So probably what they did is they, I will tell you this, it's a little hard to know. That's kind of unusual. Typically when you power it up, it establishes where it is. It goes through, it finds satellites and it locates its position. These Pixar's flight controllers with the GPS antennas they have can pick up 17 satellites. Okay, they can know exactly where they are. Now, I will tell you that I have had a drone where the fail-safe wasn't set right. Now this was 9 years ago, so it's been a long. That's a lifetime in the drone world. But it wasn't set right, and they put it into fail-safe, and it flew off, and we've never seen it again. So, but I will tell you that was, like I said, 9 years ago. Why it did that, I'm not exactly sure, unless it had a point in there at some time, or when they created their flight plan, they created it, with a home point or takeoff point from wherever it was. I don't know. That's a little unusual, but that's why. That's why you want to check and recheck when it comes to that kind of stuff.
Yeah. Cool.
All right.
Anybody have any other questions?
I hope I didn't put anybody to sleep.
So this radio stuff is kind of complex. You've got lots of radios going on your drone. You've got the GPS, you've got the camera, you've got the remote, and you've got the ground control. All of those are working together and hopefully not shorting each other out and not interfering with each other. And then you've got a lot of other interference in the environment. You're going to get a lot of interference from your motors. So you need to keep your antennas a long way from your motors.
Well, what you can run into, just to clarify, most of the time you see these drones and the GPS antenna is mounted like 3 or 4 inches above the deck, and that's because the pulsing electricity current that goes through the wires, through the ESCs, electronic speed controllers, and out to the motors, it's putting off a lot of RF, electromagnetic frequency. And so they typically put the GPS antennas, elevate them to keep them away from that. Now I have flown drones and put that GPS puck right on the deck and not had problems. But generally speaking, they want to keep it above that to avoid interference. But it's not interfering with, it's not going to get interference from your transmitters. It's really, if it gets any interference, it would be that electronic speed controllers. But again, that's why most of these have GPS antennas that stick them about 4 or 5 inches above the electronics.
And then you're not going to be able to get the other antennas very close to the motors because you don't want them to get whacked by the propeller.
Well, yeah, that's the antennas. Yeah, but that's the only ones that have that real potential are the ones like this for these. These are the ones you're going to want to try to set out so that they're not, the carbon fiber isn't getting in the way of them, as well as you're not getting interference with the carbon fiber plates. And you want to try to set them at 90-degree angles.
Yeah. So no binding to the carbon fiber. Bad idea.
Yeah.
Or if you've got aluminum or anything
Well,
else.
these mostly receiver are in a plastic case. So we use double-sided sticky tape and zip ties to mount them to the plate. It's the antenna wires that you want to make sure you don't have like strapped to the side of the I'll give you an example.
And that's because your antennas need to be a size that matches the wave that they're going to receive.
Right, exactly. But see, if you mounted and stuck that and zip tied that antenna right to that, then you'd have a fair amount of attenuation. You lose some signal because of that carbon fiber. That's what you want to try to avoid, whether it's a plate or whether it's a tube. You want to try to avoid that. That's why with the aircraft we have here, they're going out at angles. I've actually had some aircraft where I built where one antenna is going this way and one of them is going this way, and two different antennas, one going laterally and one going vertically, so that if the aircraft turns, something along those lines, you have less chance of having any reception problems. Though I have never had a reception problem with these radios. So, okay. Well, Ken, I'm going to hand it back to you, and I'm around if anybody has any questions. I'm going to pop my email address here in the chat if anybody wants it.
Well, thank you very much, Ron. We really appreciate your expertise on the antennas and the radios, the RF transmissions that are going on here. Just because there's a lot of RF on each drone doesn't mean that they're going to interfere with each other so much, because they are connected to different signals. That's very different than how the old crystals would work. You typically only had like a number of crystals, and then each of those crystals had a frequency that was connected to them. And that's not the way that these work. Hopefully that you won't have any problems with interference between drones, but you do have to set them up to connect properly to the your remote control and your ground control. And your ground control can be shared, so people can pick off your pictures and other types of things, and the judges during the competition will be able to watch that. I believe. Is that right, Ron?
Yeah, they should be able to. So the judges should be able to. We'll have like a monitor set up so they can tune into the transmitter channel for the video transmitter, so they can see what their camera sees, as well as they'll have the net ID for the telemetry radios, so they can monitor and see where the drone is it going the right places. And also, I think the judges are going to have a requirement that the students have to submit their flight logs from the drone, so they can analyze those pieces of it as well.
Yeah. So if there's no other questions, we're going to be doing one more coaches clinic, and that's next weekend, next Saturday. And it will be on the competition, how to manage the competition, how to manage your team at the competition, the different, going through the rules again, and making sure that you're prepared to do the competition. And hopefully the day or very soon after that, we will open up registration for this year's tournament, which is going to be in Dallas. And then we're also going to open up opportunities for coaches clinics during the summer. And we're going to probably do a coaches clinic in the Chicago area, a coaches clinic in the New York area, a coaches clinic in the West Coast, and a coaches clinic in Dallas. So all of those will be available to you, hopefully by the end of this month, probably around January 31st. So any other questions? Last chance. Okay, give me an email or ask Ron, send him an email. And if you have any other questions, and thank you all for being here. Appreciate it. See you later.